Hi everyone, thank you so much. Now we are back again with our next session, and this is gonna be with Sai Karthik, and he's gonna be talking about securing C native web and API endpoints. So let me just, without further ado, get him.
My name is Sai Karthik. I am the lead technologist for cloud security and DevSecOps from Checkpoint. And I'll be talking about securing cloud native web and API endpoints today. So this is essentially an open source project that my firm has built over the last couple of years for addressing a very specific problem that cloud native uh, web and API endpoints have from a security perspective. Here's the agenda for the conversation. So I'll begin by addressing the problem that we have at hand and highlighting some of the typical issues that the industry faces when building and securing cloud native apps from a conventional old school WAF point of view. We'll be talking about the project that we are manning and handling at the moment, which is OpenAppSec. And we'll be talking about how OpenAppSec's signatureless approach to securing web and API endpoints is a bit of a unique one. It's a bit of an experiment in the industry at the moment that's proving successful. We'll delve into one example of how it secures a, a zero-day attack. It's a specific one. We'll have a payload by payload, blow by blow breakdown on how it actually secures or how it actually defended against said zero-day attack. We'll have a very quick demo on how easy it is to um, work and operate this particular tool, and then we'll immediately break for takeaways. Now, starting with the challenges with old school WAFs. Let's start way high in perspective. So conventional application security practices versus modern application security practices. WAF and securing web and API endpoints is a large subset of it, but let's talk about the grander practice for a moment. When we're talking about conventional application security practice, you will realize that this practice was built for a completely different world. It was built for quintessentially monolithic applications. This particular kind of practice was heavily reliant on signature-based detection, where you had a rough or specific, sometimes a specific idea on what kind of pattern you were looking for in order to protect an application, and you would enforce it. This quintessentially was enough back in the day. But as time progressed, we saw that conventional application security practices, especially from securing web and API endpoints, was becoming more tedious. It took a longer time to enforce. It had a lot of false positives. And this was the transition period between the conventional AppSec practice and the modern one. Now, moving over to the modern AppSec practice, you will realize that it has a wildly different target audience. Firstly, modern AppSec practices prefer to mold themselves for modern applications. This could be microservices-based applications. This could be microservice applications deployed on a more cloud-native style deployment. But on a flip side, this means that there are a lot more moving cogs when it comes to configuration. So signature-based approach quintessentially has to be replaced or has to be augmented by something else uniquely, which will be beyond that, and which at the very most should be transparent to it. The problem that we spoke about before, signature-based having a large amount of false positives and taking a long amount of time to implement, should be particularly addressed by a more automatic approach, which essentially means zero policy management for anyone who's administering the solution. This is what legacy versus modern should look like. Now, the gap is building this modern AppSec practice. And so that's where we are kind of pushing the envelope with this open source project at the moment. But before we get to that, let's talk about specific problems with just signature because that's the crux of the conversation. Today's uh, uh, old school WAPs, so, essentially the core of today's WAPs, right, which is still signature based, has a built-in flaw in today's world, which is that signatures are often general. When you're detecting attacks, signatures are quite general. You have a catch-all signature which doesn't uh, do well when it comes to specifically crafted requests that target specifically uh, vulnerable parts of your applications. And so you need specific signatures for that, right? And these signatures take time to get published. And this basically means you're left to defend with a generic signature, and you don't have the ability to prevent zero day, essentially. Because by the time the zero day, the exploit is about, you're still in zero day, and it takes a couple of days or so for the newer signature to roll out, for the more crisp and concise and precise signature to roll out. Now, this is the trailing issue of signature-based WAPs. And this continues. This actually worsens with variations of exploits, variations of the vulnerabilities as well coming into the play. Now, what do we do about it? As uh, as a cybersecurity company in the industry, we've been pushing the envelope with this particular open source project. We call it OpenAppSec. The the crisp of it is this, right? OpenAppSec is an open source WAF. It's Apache 2.0 license, and the core of this WAF is an ML-based engine for decision making, as opposed to static rule-based decision making or signature-based decision making. And it is proven effectively in the industry at the moment to protect against OWASP top 10 and zero-day certain zero-day exploits as well, like Log4j, Spring4Shell, Text4Shell. These attacks have been defended against without any prior signatures, and this has been validated by third parties as well. We'll talk about this in slides that come after this. Again, we harp on that no signature approach. We harp on that no signature approach. We let machine learning models build and understand um, the context in which they operate, and the machine learning models make the decisions. And the main key difference between predominant WAF vendors today and this particular tool is it is a very cloud native adept WAF, which means that it can be deployed in unique cloud native scenarios. Most of today's conventional WAFs are WAF as a service where they're hosted in a certain point of presence, and there is DNS record termination, traffic is rerouted to that, and then from that to the application that is trying to protect. When your application is cloud native, when there are hundreds of different endpoints that you're exposing, you would rather need a WAF that's closer to them, within them, and that's where we stand with our open source project. And the curve of it is that it also has other aspects around cloud native, aside from being adept at cloud native deployments. The configuration of it is as well very adept to being used in uh, the life cycle of a cloud native app. You can build the configurations of it. You can operationalize this entire product, this entire approach in any particular pipeline. And there are diverse and various approaches for you to manage them. You can have a local management where you're just managing it based on declarative files, or you can have a central management with a GUI, and you should be able to manage it from the GUI for those of us who are more GUI adept. And There are variations of this. I will be only speaking about the community project today, but there are, of course, premium and enterprise variations of it for those of us who represent firms that require a bit more handholding. Most of the features, the core of it, the ML model of it is full-fledged available from the community edition. Now, connecting WAAP, these are all the different deployment scenarios that we support, and you're noticing a very cloud native oriented deployment style being displayed here. You have, excuse me, of course, quintessentially Kubernetes is the house of anything cloud native. But of course, you have other unique deployments. This particular WAF can be deployed on a Linux server, on an NGINX instance, if you prefer. It can be deployed as a Docker image. You can have it deployed on top of API gateways, popularly Kong at the moment. You also have upcoming deployments with Envoy and Emissary around the corner. And this particular, the commercial version of this, and of course, the open source as well, has existed for a year or so now, and beyond that, in some other shape or form, and it has been accredited multiple times for its uniqueness to being able to defend against um, deep attacks, against especially zero-day attacks. Here's the report from Gigamon. There is a report that specifically calls out us being leaders in this segment. There have been, there have been instances where we have effectively defended against Log4j and Spring4Shell and Text4Shell attacks, and those have been documented as well. And very recently, maybe almost a half a year ago, we have successfully defended against the most popular bypass technique for a WAF in general. This was a JSON-based bypass. It's quite a unique read. Clarity's security research team, Team 82, did a deep dive on numerous vendors across the board and identified Checkpoint to be the only vendor to be able to defend against this sort of bypass technique. And here's a bit of artifact on that, a bit of snippet on that, of how we are able to defend it. So OpenAppSec is being called out by Clarity for defending against the specific JSON bypass technique. Now, circling back, we spoke about the accolades that it received, and I hinted at it being a more ML-oriented WAF than a WAF that specifically relies on signature-based rules. So very quickly, these are some of the more, excuse me, the more important machine learning models that have an influence on the decisions that are taken. We have a machine learning model that keenly focuses on user behavior. Every single user's unique behavior is tracked over a long period of time. Crowd behavior, there's a specific model that takes into account the behavior of the grander crowd. This is very useful for understanding false positives. When a lot of people do something wrong, it possibly means that the wrong thing is not wrong, right? So, and you can do trusted users where the WAF looks at a particular user and it's able to understand what a good behavior is based on the trusted user, and a model is constructed based on that user's behavior. Transactional models that document and understand the pattern of transactions, models that document and understand the nature of the application that is trying to protect. And there are a handful of other models that I'm not speaking of right now. Suffice to say, all these models have a weigh on whether the request in that particular traffic is malicious or not. This is what makes it unique. So let's go deeper into this particular contextual model of machine of WAF. The decision-making flow of this particular tool can be summarized in two stages. First, you have the basic filtering stage, and we're looking at atomic indicators. And I use that word atomic very specifically. You will understand it in the example. So this is a signature-based approach here, of course. So the signatures we're looking for aren't whole SQL signatures. These aren't whole cross-site scripting signatures. We're looking at atomic characters, the presence of specific atomic characters. And if these characters are present, they bump up the suspicious score to a certain level. And if the score is high enough, it is passed on to the advanced analysis engines, the roster of engines that you saw from before. And these engines will individually evaluate the request, and each engine will individually assign a score, and then a cumulative of that score is taken to understand whether we pass the traffic or whether we block it. This is the high level flow of it. Stage one being a filter for basic atomic indicators, and stage two being a more advanced analysis of the entire transaction with context. Let me break it down with a specific example in mind. Now consider that we put in a very basic SQL injection. Typical WAAPs will look for this entire pattern as one signature. Now we look at it in a very different way. We don't care for the entire string. We look for individual characters, atomic characters within any particular request, and we assign a score to it. So here's a rundown of the kind of scoring this particular string would receive. And this is how the first line of filtering is done. We look at all of these individual characters and their presence, and if the score is high enough, we pass it on to the next level of filtering for a much more informed decision to be taken. Remember, this is not a deny. This is just the first stage saying that this is something that's quite suspicious. Now, when we move on to the second stage, that's where the more advanced models, the more advanced machine learning models come into place. Now, recall the models that we showcased from before, the user reputation model, the crowd behavior model, right? So there is also the payload model, the URL model, and the parameter model that I haven't spoken of before, but add great context to this particular transaction. So when this URI, when this request comes in, each of these models assign a score, and that is then taken into account for a decision. So the user reputation model will take into account the reputation of that specific user. The payload score model will take into account the payload that's present in that particular request and compare it to the payload that typically has been present for that kind of request. And same thing with URL, same thing with parameter. It looks out for crowd behavior as well. These two scores that are attributed look for crowd behavior as well, as a baseline to be compared with. And here's a very quick snippet of how any particular complex payload is broken into. I won't delve too much into it, but the fact is that again, atomic characters add an increased score, and then the advanced modules take a more informed decision. This is how it works. And now let's look at very specific real world example of how the two engines work hand in hand and how they're able to quickly take an informed decision. Log4j, by far the most popular example, and so we'll pick that because pretty much everyone is aware of this. Let's pick one specific string here, and let's try to see how OpenAppSec deals with it. We'll go with log4shell style exploit to begin with. Two stages. Again, consider that a request for particularly a log4shell exploit or a generic log4j exploit is pushed. Now, This is assuming that we don't have signatures, right? This is a 0 day. Effectively, from the perspective of the fact, this is a 0 day. And so when the request comes in, the first stage looks for atomic indicators. Here, it specifically looks for the presence of, here's a dollar, for example. Here's a bracket, here's a curly brace. So these and a handful of other atomic indicators bump up the score of stage one. And because of that, the score is high enough for it to be passed on to stage two. This is how it actually goes through, right? And in stage two, we have realized that there are some modules that often almost always weigh in. The user reputation module is by far your strongest one for identifying suspicious behavior. If everything else fails, user reputation still is quite smart and adept enough to say that this user has no reputation in my standing. For attackers to be able to bypass this model alone, they'll have to build a good reputation for a long period of time or hijack another user's uh, ID and use that user's reputation for a long period of time. So it has to be a more complicated attack. The user reputation module assigns a moderate score saying that I don't have any reputation against this user. The payload score is again 4.2 because there are two characters in there, not more, not more than that. So that's a reasonable score. But the URL one, the URL score is quite high because this is quite a unique URL compared to any other URL that was sent to that particular endpoint over the past. And the parameter score was completely more evident of it because the parameters that was associated with certain with the URL was quite unique. Those weren't present before. And so this is where the request got flagged off and it was dropped. So this is actually how the flow went through. Checkpoint was not, at this point of time, we had not put in any signatures into OpenAppSec to identify log4j uniquely, log4j's exploit uniquely. So we weren't looking for JNDI, we weren't looking for LDAP, we weren't looking for any of these characters or traits. Now, we know how it works. I will quickly cover how we operationally work with them in production. Your management options are twofold. Firstly, you have the option to manage them completely on CLI. Now, this is for those who are more um, adept with working with policy as code. This is for those of us who have a life cycle for our application which is completely woven through a pipeline. And so you can write the configuration of the endpoints you're exposing as well in the pipeline, and then the security policy for those in the same pipeline and have it churned out together. And it is it's one of the most, I would say, DevOps pro DevOps WAAPs out there. Or contrarily, you can have a complete SaaS-based management. You can introduce policies, create new assets, configure them, triage them completely in the cloud. Or third middle ground is a bit of both. You can introduce new assets and you can secure new endpoints and write the policies for them locally. The logs are still sent to the cloud. Their definitions are still visible in the cloud. The cloud is more for a visibility point of view. When I say the cloud, I'm talking about the dashboard, of course. The SaaS dashboard is visible and it is for visibility alone, but the policy is still maintained locally. Now, this is best of both worlds. So what we will do right now is we will switch for a quick demonstration, and right after that we will wrap. So let's begin by taking a look at the kind of pods we have here. Now you'll notice that we already have an NGINX deployment, Ingress NGINX deployment. Now, what I will be doing is I will try to mimic this deployment and introduce my own Ingress controller in place of this. Now, this particular Ingress controller is exposing a web endpoint which is vulnerable to an attack. So this is the web endpoint in particular. I will try to exploit this web endpoint with with a very obvious string right here, and you see that the exploit kind of lands and a random document is pushed out. This works. Now, let's take a look at a scenario where we introduce AppSec in there, OpenAppSec in there, and we configure a basic policy and we see how it defends. So let me quickly download and install OpenAppSec. This is me downloading the OpenAppSec binary. Happens very quick. It's not too huge. And here's me putting it out in prevent mode. And very quickly, I'll start to configure the policy right during deployment. So I will go with duplicating the ingress. I'm not going to replace it. I'm going to duplicate it. And I'm going to insert myself into this is the ingress that's already in place. Ingress rule or object that's already in place. I will try to insert myself into it. And I will save my configuration as a YAML file. Now AppSec is being deployed. OpenAppSec is being deployed, and parallelly the configuration that I already designed for it now will be installed. Now what you will notice is we use custom resource definitions. As far as Kubernetes goes, we use custom resource definitions to house our policies and house every other scaffolding configuration around it. So I'll give you a quick brief on that. And realistically speaking, if you were to just edit your policies, your custom resource definitions, you would be good. You don't even have to care for a central dashboard. The logs can be churned out and sent to some place for you to analyze, and you don't even require a dashboard for this. Now let's just very quickly take a look at some of the custom resource objects. So these are all the creds that were CRDs that were created. If I were to just view the policy, we should have already installed the policy here. And you see you have OpenAppSec best practice. Now this is the best practice manifest. You'll see everything that's pertinent to the configuration being defined here. It's deployed in prevent only. It's deployed with certain security practices in place. Its response to a certain request, a malicious request, is going to be 403 forbidden. And you will see that this is going to be enforced now once when I try to launch the attack again. Now, same attack. Now you see I get a 403 forbidden because that's how I designed for it to respond. Now let's take a quick look at the logs. And you actually see that we have an event here, an event of prevent specific to this particular exploit. Now this entire management is done locally, completely locally. And you can use the CRDs alone and you can call it a day. Or you can centrally manage it as well with our SaaS management portal. The SaaS management portal up to a certain amount of requests is free. So even in production, you can essentially use it because it's provided as a convenience for the open source project. So I have the portal right here. So let me log into it. Seems like I already have a deployment here. Let me go ahead and clean it. And let me go back to the beginning. Yes. And now let's begin a deployment. I'm going to create a new Kubernetes profile. I'll call it Kubernetes Agent 2. We want an NGINX style deployment, but recall that we also do for con, FYI. Now all I have to decide is the kind of management style. I can go declarative where the policy is still configured and doled out at the cluster level, at the Kubernetes cluster level as CRDs, or I could just make the management central, where all the changes and policies and enforcements are done from here, from the SaaS management portal. So all I have to do is now connect. I already have the NGINX Ingress controller with OpenAppSec present, the Kubernetes cluster. Now I have to just connect it back to the SaaS dashboard. Just download the binary required for this, and I will execute it with the respective key in place, with the respective token in place. And now all the custom resource definitions that I have done in this particular cluster from before is now being uploaded to the cloud dashboard. And you will see those things manifest over there. And there you go. It's been deployed, and now the resources are being pulled and uploaded. And done. Let's take a look at the assets tab now. And there you go. Again, we have a basic asset defined to support the policy of that particular deployment. Look at the agents tab, and we should see one of our agents reporting in. There you go, Kubernetes agents 2. And now I will go through and execute the same attack. And now we will see the log being showcased not locally but centrally. Same dashboard, same vulnerable application, Acme audit. I'll put in the SQL injection. And now you see a much more refined because the policy is different now. The policy is not a 403, it's a redirect. Now you get a clean attack blocked display. And from the dashboard point of view, we can go to monitoring and it should be able to showcase the logs to you. And there you go. The time is a bit askew, but it, uh, it just a time zone issue. And you see the event here being showcased. And that's quite it. So let's very quickly wrap up. There are only a couple of things I want you to remember at the end of this conversation. OpenAppSec is a completely open source uh, project that's driven by Checkpoint and by the community in general. It's unique. There is no WAF project out there like this, commercial or open source or otherwise. So I would highly implore you to take a look at it. I just ran through the um, hands-on lab myself. This thing is available for anybody to sign up for and try. I would implore you to try this again. The artifacts will be provided to you. And this is a uniquely cloud native WAF. There are very few out there that are cloud native in nature. And by virtue of that, it also has its policy uh, doled out in a very declarative manner. You could use your pipeline to define the policy of your firewall, which is quite a rare thing to see today. So those are the few things I wanted you to remember. Again, you could visit openappsec.io for more information on the project. Please hit up our GitHub page if you prefer to directly look up the source code and contribute yourself. Please do. We have various different social avenues for you to reach out to and chat to us about regarding the project. We prefer to hear from you as much as possible. So I'll see you folks out there.
Thank you so much, Sai. I don't see any questions at the moment, but I'm sure people would reach out to you. So, thank you so much for the wonderful session on OpenAppSec. Everyone, if you have any questions, please feel free to reach out to Sai. Thank you so much, everyone. Take care. Have a great day.